Hello student, welcome to Vidyanest. In last class, what did we leave? We terminated straight line in space related to 3D geometry. Now, the continuation will be on. We will now render from straight line to plane. Straight line to plane and the combination of straight line and plane. See, first of all, we will discuss about the concept of plane. This is x, y and z axis, and you have had the idea of direction, cosine and ratios of line. Now you draw one plane. Let us discuss about equation of plane. Equation of plane. How to find the equation of plane? See, this is one surface. Let a plane intercept x-axis at A, y-axis at B, at the intercept B, and this is A, B, C. Okay. Now, on this surface, it is look like tetrahedron. On this surface, there will be a line drawn on this plane or lying on the plane. Okay, there is a line on the plane, and from origin a perpendicular is drawn on this plane. Okay, that means the line is perpendicular to a line lying on the surface ABC. Let magnitude of this is D. Magnitude of ON is D. Then with respect to vector, we can write in terms of unit vector, where n cap is unit vector along the normal to the plane. Along the normal to the plane, and n is foot of perpendicular. So ON is equal to n cap D. Let position vector of P is R. Let position vector of P, that is OP is equal to vector R. Okay. Then what about Pn? Then vector Pn is On minus OP. What is On? On is n cap d. On is n cap d. What is OP? As per our assumption, R. Now, n cap is unit vector along the normal to the plane. That means I can write On dot Pn 0 because they are perpendicular. What is On? N cap d. What is Pn? Now, d is a scalar value. It will be dropped from both sides. And n dot n n cap is unit vector. N cap is unit vector. Therefore, its magnitude is 1. So, its magnitude 1. That is vector equation of a plane. Vector equation of a plane. Okay. Now, from vector, you can convert the equation to Cartesian form. This is the vector equation of a plane. Now, Cartesian form. We have come to know, therefore, vector equation of a plane, we have come to know R dot n cap is equal to D. What is D? Few minutes back, you have come to know that distance is measured D, perpendicular distance is D. Then perpendicular distance is D. So, vector equation of a plane, we have got R dot n cap is equal to D. Now, let R is any vector, so I can write it in terms of x, y and z. That is vector R. N cap AI, Vj, Ck. Now put this in place of this. What is R? Xi, Yj, Zk dot AI, Bj Ck is equal to D. Now it is a dot product, so the corresponding component will be multiplied. Cartesian equation of a plane with direction cosine ABC. Okay, with direction cosine ABC. That is Cartesian form of plane. Now, suppose this plane passes through x1, y1, z1. If the plane passes through x1, y1, z1, that means this point will satisfy the equation. What is meant by satisfying? The equations x will be replaced by x1, y will be replaced by y1, z will be replaced by z1. Okay, therefore x1, y1, cz1 is equal to d. Let us level it by 1 and level it by 2. Now you subtract 2 from 1 by 1 minus 2, we get so we have got a new equation of plane. Equation of a plane passes through equation of a plane passes through x1, y1, z1. Now what will be its vector representation? Vector equation of a plane passing through a fixed point. What will be its equation? You see, vector equation of the plane, we have got r dot n is equal to d. Now, it passes through a fixed point. Let it passes through a fixed point R1, say. Put here, it will satisfy the equation like Cartesian. The same thing will be recorded. R1 dot n. R1 dot n is equal to D. Let us level it by 3 and this thing by 4. So by 3 minus 4, we get, what we get? R minus R1 dot n cap is equal to 0. That is vector equation of a plane passes through a fixed point R1. Hope you could follow. So that is too important property, basic level property, but important. Hope you could follow. Now, we will find the angle between two planes. Suppose there is a plane like this, and with this we are drawing another plane. So this is the angle between them, theta. Let this plane is ax plus by plus cz plus d is equal to 0. And that plane is a1x plus d1 is equal to 0. So, angle between two plane means the angle between the outer normal of the two plane. So, what is the direction cosine of this? A direction cosine of the plane is the outer normal of the direction cosine of the outer normal of the plane. Direction cosine of this plane is the outer normal. Direction cosine of the outer normal of the plane. So you have to find the angle between that, and that concept even you got in vector. What is that? Cos theta. A1, A1, B1, C1 by root over of a square plus b square plus c square into root over of a1 square plus b1 square plus c1 square. From where did we get this? We get this from the formula of vector. Hope you can remember. A dot b mod a mod b cos theta. So cos theta will be A dot b by mod a mod b. So this is cos theta. This is the angle between two planes where theta be the angle between the above two planes. Once you get the angle between two planes, then some condition will come. One condition will depict the perpendicularity, and one condition will raise the concept of parallelism. When perpendicular, if theta 90 degree, if theta 90 degree, cos 90, A1, B1, C1. What is cos 90? Cos 90 is 0. This is magnitude. Cross multiply means if I cross multiply, I will have this result in our hand. Condition of perpendicularity of two planes. Now, condition of parallelism. If you get two plane parallel, so what will be theta? 0 degree. If theta is equal to 0 degree, cos 0 will be what? Cos 0 will be 1. Let's then cross multiply and simplify. You will get A by A1, B by B1, C by C1. Condition of parallelism of two planes. Condition of parallelism of two planes. Now, in case of vector, how to find the angle? See, in vector form, two planes are like this. So, cos theta, see that N1 dot N2 gave you A1 plus B B1 plus C C1 condition. And get theta from here. So, this is the condition of perpendicularity of planes, parallelism, and the condition of finding the angle between two planes. Okay. Now the question is how to find the angle between line and plane. Line and plane are two different geometrical figure. Okay. So, how to find the angle between them? Angle between a line and a plane okay. So, and there is the line. Two different geometrical figure. Okay. Their dimensions are also different. Then how to find the angle? So, direction cosine of the line LMN, direction cosine of the plane ABC. Now, actually, angle between a line and the plane is the angle between a line and outer normal to the plane. If direction cosine of the plane is this, then direction cosine of the line is also this. So if that angle is theta, so this angle will be considered as 90 minus theta. So angle between line and plane is, it represents angle between the line and outer normal to the line. Outer normal to the plane. Line and outer normal to the plane. So already we have come to know the method of finding the angle between two lines or two planes, means two same type of geometrical figure. See, few minutes back we have discussed it. Cos theta, A1, B1, C1. Here theta was the angle between two same type of geometrical figure, that is plane. It also be applicable in case of two line. Then here line and plane. Line and planes, between line and planes angle is theta. But once you want to convert it to find the angle between two, same type of geometrical figure like two lines, then its complementary angle you have to take. Complementary angle. This part you have to take. So, angle, if theta be the angle between a line and plane, then pi by 2 minus theta be the angle between line and outer normal to the plane. Line and outer normal to the plane. So, in that case, cosine of pi by 2 minus theta. Cosine of pi by 2 minus theta. Okay? That means AL plus PM plus CN by root so this is the angle between line and plane. Now cos pi by 2 minus theta is what? Sin theta. L PM CN by root of okay. Now if theta is 90 degree from this state to this state, if theta 90 degree, sin 90 is 1, put here, square both side and simplify, you will get A by L, P by M, C by N. That is the condition of perpendicularity of line and a plane. That means this condition which is visible here, it's look like what? It look like the parallelism concept of a parallelism condition between two planes or two lines. But once you get two different geometrical figure of different dimension, so this is the condition of perpendicularity of a line and plane. Then what about parallelism? If theta 0 degree. So this is the if theta 0, put here you will get 0. Condition of parallelism of a line and plane. Condition of parallelism of line and plane. See, there is a question like this. If the angle between the line and the plane 2x minus y plus root lambda z plus 4 is equal to 0 is such that sin theta is equal to 1/3, then lambda is option A minus 4/3, option B 3/4, option C minus 3/5, option D 5/3. So this is the question. It came in JEE exam. (2011). Now, how to defend the sum? Here, angle between this line and that plane is theta, and sin theta's value is also given. Sin theta means what? A L. A is 2, L is 1. L plus Bm. B is what? Minus 1. B into M. M plus Cn. Root lambda into 2 by root over of 2 square whole square into root over of 1 square, 2 square, 2 square. Now, sin theta is given what? In the question, sin theta is given 1/3. Put here and complete the calculation. See, instead of sin theta, you can put 1/3. That is, you see 2 into 1. Earlier we got 2 into 1 minus 1 into 2. So 2 minus 2 cancel. 2 root lambda 5. 2 square plus 1, 5 plus lambda root 9 means 3. 3 cancel. Now we are about to reach the conclusion. See, here we have cancelled 3. So square both sides. 4 lambda is equal to 5 plus lambda. 4 lambda is equal to 5 plus lambda. Cross multiply. 5 plus lambda is equal to 4 lambda. So 5, 3 lambda. Lambda's value is 5 by 3. Lambda's value is 5 by 3. So, is it that much of tough? No. It is a JEE level sum. But if you know this property, angle between line and plane, the sum will be so simple.